Board number 12. It says approximate the square root of 32 to 1 decimal place. Alright, so the first thing we need to do is decide where does this fit in the line of perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and 6 squared is 36. And obviously 32 would fit between these two. So we're looking approximately somewhere between 5 and 6, 5 point something up to 6 is going to be the square root of 32. Well, 32 is definitely closer to 36, and it asks us to find it to the tenths place. So it's obviously not 6, because that's 36, but it could be 5.9 squared. It could be 5.8 squared. So we could do, and then what we're gonna do is figure these out and see which one of these gets us closer to the square root of 32. So of course you would do this, if you can't use the calculator, you would do it by hand, right? But I'm making a video, so I am going to do it with the calculator to make things go faster. 5.9 squared is 34.81. 5.8 squared is 33.64. Okay, so obviously this is closer to 32 than this is. 5.7 squared is 32.49. Could be that one. It's not going to be that though. And 5.6 squared is 31.36. Okay, so this is really close to 32.5. So this is a half away from this, and this is more than a half away. So this is actually closer. So if it asks us to approximate 32, the square root of 32 to 1 decimal place, we would say it's 5.7. Number 2. Draw on this grid a triangle with the hypotenuse of 25. So if it's asking us to draw a right triangle and it's talking about a hypotenuse, it's talking about using the Pythagorean theorem. So we have a squared plus b squared equals c squared. Well, it's telling us that the hypotenuse is 5. So a squared plus b squared equals 5 squared. Therefore, a squared plus b squared equals 25. And then we need to find two perfect squares that when we add them together, it would be 25. So, going back to the perfect squares that we just did, I'll rewrite them. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. So we need two of these perfect squares to add up, when I will place them in here, to add up to 25. So 1 and 16 won't work, 4 and 16 won't work, because that's 20. 9 and 16, oh, that works, because 9 plus 16 is 25. So if I replace this with 9 and 16, that does equal 25. But this was a squared. If a squared is 9, what is a? A equals 3. And this is b squared. And if b squared equals 16, then what does just b equal? B equals 4. So we need to have a right triangle with sides 3 and a side of 4, and then make the hypotenuse. That's going to be, that will be 5 squared, or 25. Okay, you can do that anywhere on here. So 1, 2, 3, 1, 2, 3, 4. There's the hypotenuse. This is going to be 3 squared plus 4 squared, so 9 plus 16 equals 5 squared, or the side length of 5. solve the following systems of equations. Okay, so what I think I'm going to do is I'm going to go ahead and take this and I'm going to solve for y, because it's almost solved for y, right? It's 1/6 y, so if I divide this, this, and this by 1/6, then I'll have y equal something. Okay, so let's see, I'll do that down here. Divide this by 1/6, divide this by 1/6, then divide this by 1/6. 1/6 divided by 1/6 is 1, so there's our y. 4/3 divided by 1/6 is the same as 4/3 times 6/1. Simplify before I multiply. 3 goes into 3 once, 3 goes into 6 2 times. 2 times 4 times 2 is 8. So this will be 8. And then I do it again right here. I have 1/3 divided by 1/6, which is 1/3 times 6/1. Simplify before I multiply. 3 goes into 3 once, 3 goes into 6 2 times. Now multiply across and I get 2. This was negative, okay? So it's really negative 1/3, so my answer is going to be negative 2x. So this is the equivalent of y equals 8 minus 2x. It's a system of equations. I have y equals and y equals, so to me it would be really easy to go ahead and set this up by substitution. So I would have 8 minus 2x equals negative 2 times the quantity x minus 4. I'm going to go ahead and divide everything by negative 2. When I do that, that's going to give me x minus 4 on this side, and over here, this is going to give me negative 4, and this is going to give me a positive 1, positive 1x. Okay, so then now I like to move all my variables to the same side, and when I do that, that gets eliminated, that also gets eliminated. I get negative 4 equals negative 4, which is a true statement. And since it's a true statement, it is infinite solution. Okay, it took 6 days to empty out a sphere-shaped tank at an oil refinery. The tank was emptying at a rate of 400 cubic feet per day. What's the radius of the tank? So the volume of a sphere, volume equals 4/3 pi r cubed. Okay, they are asking us what the radius is, and they don't flat out give us this, but they do tell us that it took 6 days at this rate. So if this is for 1 day, if this is the volume that emptied in 1 day and it took 6 days to empty it out, then I would just multiply those. I would have 6 times 400 equals 4/3 pi r cubed. 2400 equals 4/3 pi r cubed. Divide this side by 4/3 pi. Divide this side by 4/3 pi. I'm going to do that in the calculator. So 2400 divided by 4/3 pi. And that is 572.95. I'm just going to make life easy and round that up to 573 equals r cubed. And now I need to take the cubed root of 573. And the reason why I take the cubed root is because I want to know the radius. I don't want to know the radius cubed, just the radius. So I need to get rid of this cubed part. So to undo cubing, I need to take the cube root. taking the cubed root of something cubed undoes it, just like adding undoes subtracting. So I will get r, and then in the calculator I'll say 573, the cube root of that. And that is approximately 8.3. Oh, and I guess I should. It is a word problem, right? So 8.3 feet is the radius. And it's approximately. Oh, let me scoot that over here. Okay. Alright, finally, a cone and a sphere have the same radius and the same volume. Solve for the height of the cone. So the volume for a cone is equal to 1/3 pi r squared times the height. And the volume for a sphere is equal to 4/3 pi r cubed. It's telling us that the cone and the sphere have the same volume. So this is essentially a system of equations, and I can use substitution because this volume for the cone is equal to the volume of the sphere. Okay? So they're asking us the height of the cone. In other words, by the time I get done, this needs to say h equals something, right? Because that's what I'm solving for. Okay, so what I'm going to do is, all of this being multiplied each other, I'm going to go ahead and divide this side by 1/3 pi r squared. And I will also divide this side by 1/3 pi r squared. When I do that, I immediately eliminate that. I'm sorry, not eliminate it. It turns into a 1. And I'm left with 1h equals. And then over here, pi divided by pi is just 1. R cubed divided by r squared. We have learned that you can take the exponents when same base and it's being divided. You can subtract the exponents. So over here, 3 minus 2, this is going to give me 1. 1 r to the first, rather. And then I need to divide this. 4/3 divided by 1/3. So 4/3 divided by 1/3 is the same as 4/3 times 3 over 1. Simplify before I multiply. 3 goes into 3 once, 3 goes into 3 once, and I'm left with 4. 4r to the first is equal to h. So h equals 4r. The end.